Good morning, everybody. Today, I will tell you some interesting stories on dark matter. What is dark matter? If you Google dark matter, then probably you will see many different dark matters. Dark matter coffee, dark matter medicine, movie, and nail polish. Of course, these are not the dark matter that we are interested in. The dark matter that we want to talk about today is from the universe. Dark matter in the universe. The universe is like a container. As Sherlock Holmes said, the world is full of things which nobody by any chance ever observes. The universe is such a world. Astronomers told us that in the universe, only 4% of the total matter is composed of normal matter, which are familiar to us, just like the sun, the earth, the moon, ourselves, and hydrogen atoms. As for the other 96% matter in the universe, it is invisible and not familiar to us. It is made of dark matter and dark energy. This talk will be focused on dark matter. What is dark matter? According to Wikipedia, dark matter is a type of matter hypothesized to account for a large part of the matter in the universe. Dark matter cannot be seen directly with telescopes. It neither emits nor absorbs light at any significant level. Instead, its existence is inferred from its gravitational effects on visible matter of the universe. The discovery of the dark matter should be attributed to two famous astronomers. The first one is Fritz Zwicky. He is a Swiss astronomer. And the second one is Vera Rubin. She is an American astronomer. Between 1930 and 1980, Fritz Zwicky and Vera Rubin carried out many influential studies on dark matter. Then the question is, how did they get to know the existence of dark matter in the universe? Actually, the idea is not so complicated. Let's consider the solar system. About 200 years ago, Newton told us that the moving speed of a planet in the solar system becomes smaller if the distance between this planet and the sun becomes larger. Otherwise, it cannot be trapped in the solar system by gravitation. The story is similar for stars in a galaxy. For stars far away from the center of the galaxy, their moving speed is expected to be small. Otherwise, the gravitation between the galaxy and the stars is weak, so these stars cannot be trapped in the galaxy. However, experimental observations tells us that these stars move much faster than our expectation. How can it be? If these stars move so fast, then they should have escaped from the galaxy. The only feasible explanation is that in the galaxy, there exists a new type of matter which is invisible to us. And this type of matter is named dark matter. Then the gravitation between the dark matter and these stars can help prevent these stars escape from the galaxy. This is very interesting. This is very interesting. But this is not the whole story. As we know, the visible objects in the universe are composed of particles. So the question is, what is dark matter particle? To answer this question, we need to get some ideas about the dark matter properties. Here are some. Dark doesn't mean black. It means transparent to light, just like a lens. This tells us the dark matter don't interact with light and should be electrically neutral. It doesn't carry any electric charge. This is the first property. The second property of dark matter particle is that it needs to be long-lived. At least, it has a lifetime comparable or longer than the universe age, so that its large portion can survive until today. Is there such a particle among the ones which have been discovered by physicists so far? The particles which have been discovered by us so far can be successfully described by a theory named Standard Model. However, in the rule of the Standard Model particles, no particles have such properties and can serve as a dark matter candidate. This is great. This is great for us and also for you, because this means the standard model is not complete and new theories are definitely required. So we can build up new theories. Therefore, various dark matter theories were created by physicists. But the question becomes, which theory is correct? To answer this question, or to figure out the correct theory, we need more information about the dark matter properties. There are several ways to achieve that. All of these methods are non-gravitational. The first method is dark matter direct detection. That is, go deep underground and wait for dark matter particles from the universe to hit the detector. Going deep underground can help shield the background particles from cosmic rays from the detector. This can greatly enhance the sensitivity of the detector to search for dark matter particles. This sounds like the visual by the tree stump, 守株待兔. And the dark matter detector is just the tree stumps. And China owns the deepest underground laboratory in the world. It is about 2,400 meters under the Marble Mountain in Sichuan province. This is probably the best underground laboratory in the world. The experiment in this laboratory is named PANDAX. Panda simply means that this laboratory is not so far from Panda's hometown. And this progress was recently reported by the famous magazine, Nature. The second method is dark matter indirect detection. That is, use telescopes to look for energetic normal particles, such as electrons, protons, and their antiparticles. All these particles are produced when dark matter particles annihilate in the universe. There are many dark matter indirect detections in the world. Here I would like to mention the one AMS. AMS means alpha magnetic spectrometer, which is based at the International Space Station. And the leader of this experiment is the American Chinese. And his name is Samuel Ting. Samuel Ting won Nobel Prize in physics in 1976 for the discovery of charm quark. The third method is collider search. That is, create dark matter particles using a particle accelerator. For example, the Large Hadron Collider at CERN. The CERN is a laboratory located in Geneva, Swiss. The Large Hadron Collider is the most expensive and largest scientific instrument ever built on the Earth. Its circumference is 27 kilometers. The cost of constructing this machine is more than 10 billion US dollars, roughly 80 billion Hong Kong dollars. This is huge. Currently, there are more than 10,000 physicists, engineers, and PhD students working on the Large Hadron Collider. These physicists, engineers, and students are from more than 100 countries, including China. In the LHC pipeline, if we take two protons moving very quickly in opposite directions and smash them together, then new particles, including dark matter particles, could be generated. So it provides us a great chance to study the properties of dark matter particles. In spite of these great methods, it is still very challenging for us to identify dark matter particles. It took half a century for physicists to find a Higgs particle. This is something really exciting. But more than 80 years have gone since we observed the existence of dark matter in the universe, but we still don't know what it is. To end this talk, I would like to quote some words said by Albert Einstein. He said, "The eternal mystery of the world is its comprehensibility." 也就是说，这个世界最奇妙的地方、最神秘的地方，就在于它是可以被理解的。Welcome to join the efforts of physicists in searching for the truth on dark matter, as well as of the other cosmic mysteries in the near future. I will stop here.